Okay, so we've been talking about inheritance and the fact that when a derived class inherits from a base class, it gets a copy of all of its members, both the member variables and the member functions. And but private members that come from that base class cannot be modified or accessed, whereas public members can be. This is a little bit annoying, to have all these private members that can't be used. After all, the reason we're inheriting is to reuse code. And it might be that a derived class wants to alter some of the behavior or just have more convenient access to those private members. And this is where the protected keyword comes in. We want something in between. Like, it might be nice to be able to say something like, well, we would like a member variable to be private to everyone else, but accessible to our derived classes. Think of it kind of like a parent will share a house key with their child, but doesn't want to leave their doors unlocked to their house all the time, right? Right. So there, we want to have this sort of capability, more flexible capability for how we label fields, so that derived classes can still use fields and members, but anyone else, any other object or function cannot use them. So that's what protected does for us. Protected members are visible to derived classes, but are treated like private members outside the base or derived class. So now we can change our rectangle and square code to be a little more flexible. So what we're going to say is that in the rectangle object, the width and length are protected by default. And then we define our code, and then the rest of the code stays the same, right? We still have these public member functions that are the constructor and the area function. And then when we inherit from rectangle inside square, because width and length are now protected, that means square can modify them if it chooses to. So for example, here in my square constructor, I first used the default constructor on rectangle. And really all I'm saying there is I'm going to pass in zeros and have it set width and length to 0 first. But then in my constructor, because I'm allowed to do this now, I come back and I set W and L equal to side. They're both equal to the same side. Now this is kind of contrived. We could have just called the constructor with side passed twice, but I'm just showing you here that now with this code, because we labeled them protected, that now I can modify these two member variables. And then area is inherited. I don't need to change area. Okay, but now my square object has at least the ability, if it wants it, to access W and L directly, and it could even modify them if it had a good reason to. Okay, so this chart summarizes the relationship between public, private, and protected. So across the top here, I'm saying X of a class member of X is public, private, or protected, right? That's how it's specified. And then down here across each row, I'm describing a different scenario. So is it possible to access this member from a member function of class X? And so for public, if the class member is public, then yes, I can access it in the member function of class X. I can also access a private member from a member function of class X, and I can also access a protected member from a member function of class X. Now let's say Y derives from X. Can Y member function access the X member? Well, for public it can, for private it cannot, but for protected it can. So that's what protected has done for us. And then can I access from any other function or code this member function of X? Well, if it's public, we can. If it's private, we can't. And if it's protected, we cannot. So, what this shows you is that protected doesn't change anything that happens within a class. Protected doesn't really change what happens outside of a class. It's just seen as private. But from a derived class, it changes how it works. So a derived class can see things that are protected, but not things that are private. Right, and so this protected keyword gives us some additional flexibility on which fields we can access in an object that we inherit from.